Dear students, welcome to s.mathguru classes. So, our main discussion is partial differentiation, partial derivative, how to solve some problems, and these are very important in engineering. All engineering courses, these are very important, very easy, very simple. You can get any semester, either it may be first semester, it may be second semester, third semester, but these are important for engineering courses. So any kinds of problem we can solve in this partial derivatives, and I want to solve in easily and very details. No one can say these are very difficult. Mathematics is nothing. If you are feeling easy, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Now let us start one problem. If v equal to root over x square plus y square plus z square, then prove that vxx, vyy plus vzz equal to 2 by v. We have to show this one. Now solution is start. V equal to given root over x square plus y square plus z square. First we find del v del x. This is del x of root over x square plus y square plus z square. We get this. But this is del v del x means vx. We can write this. But we know this formula ddx of root x 1 by 2 root x. We know this formula. When we get this formula, if this x both are same. If x same, then answer is 1 by 2 root x. But here x square, y square, z square, this is x. These are different. So using chain rule, by using chain rule, we can write this formula. So this under root is x, here also x. Then we write this formula. So under root is x square, y square, z square. It must be here. Now we write this one here. This. And here extra writing, then we get here also extra. Ultimately these two will be cancelled. We get del x. This cancel del x and this, we get this one. But we get this formula root x dx. Root x dx means what? 1 by 2 root x. So this will be 1 by 2 root x. X means x square plus y square z square. And we differentiate partially with respect to x. Then x is variable, others constant. Del x of x square means twice x, and y is 0, z is 0. And these two cancel. We get x by root over x square plus y square plus z square. This is our vx we get. Vx is this. But in our result, xx given, vx is given, then again you differentiate. If again you differentiate, what we get? Del x of vx. This is del x of this x square plus y square plus z square. This one, we get this. But we know division formula ddx of fx by gx. In division formula, we know this is denominator whole square. Denominator ddx of numerator minus numerator ddx of denominator. This is our division rule or quotient rule. Fx by gx, denominator whole square, denominator ddx of numerator minus numerator ddx of denominator. So here v del x and vx means vxx we can write. And this is using this quotient rule, root over x square plus y square plus z square whole square. This is root over x square plus y square plus z square. del x of x minus x del x of root over x square plus y square plus z square. We get this one. Now this implies Vxx this equal to denominator this is root over and whole square, then root over is cancelled, we get x square plus y square plus z square, and here we get root over x square plus y square plus z square, and del x is 1 minus x, again using chain rule or without using chain rule, directly we want to write this result. So we know dx of root x is, we get after calculation we get this result. Direct result is putting here 1 by 2 root over x square plus y square plus z square, and this is twice x plus 0 plus 0. Directly I have written this result. No need to show chain rule, because if we several times using chain rule, then solution will be long. So this will be x square plus y square plus z square remains same, and here we get root over x square plus y square plus z square minus this 2 cancel, x square by x and x square by root over x square plus y square plus z square. We get this one. So if we taking LCM, this is our LCM. LCM is root over x square plus y square plus z square, and this root over cancel, z square minus x square you get. So this minus x square cancel, minus x square cancel, we get Vxx equal to y square plus z square by this term also here, x square plus y square plus z square, and this will be x square plus y square plus z square into root over x square plus y square plus z square. This one we get. Just x square is cancelled, y square z square, and this one remains same. So when we differentiate partially 2 times second order derivative, in our answer denominator x square y square z square and root over this, and numerator we get y and z, y square z square, x is absent. Because we differentiate partially with respect to x, this x square cancel, then we get y and z. Similarly, no need to show the remaining terms. Similarly, if we add vyy, then here y will be absent. We get x square plus z square, and denominator remains same, x square plus y square plus z square root over x square plus y square plus z square. Again vzz, zz means here z will be absent, we get x and y, x square plus y square, and denominator x square plus y square plus z square root over x square plus y square plus z square. We get this one. So these are the values of Vxx, Vyy, Vz. Others no need to calculate. Directly write this. Skip some step. Now our aim to prove this equal to 2 by V. So taking left hand side. In our left hand side we get Vxx, Vyy, Vzz. First we putting the value of Vxx. So this will be y square plus z square by x square plus y square plus z square root over x square plus y square plus z square, and this one vyy means x square plus z square by x square plus y square plus z square root over x square plus y square plus z square plus vzz. Vzz is this one vzz. So this will be x square plus y square by x square plus y square plus z square into root over x square plus y square plus z square. We get this one. Now our LCM is this, LCM is same, so taking LCM, so LCM is x square plus y square plus z square root over x square plus y square plus z square, and here we get y square plus z square, x square plus z square, x square plus y square. So this denominator remains same, x square plus y square plus z square root over x square plus y square plus z square, and here I get x square 2x square 2y square 2z square, taking 2 common we get x square plus y square plus z square. One term, one line I skip, and these two are like terms, this will be cancelled. We get 2 by root over x square plus y square plus z square, and 2 by, this means v, 2 by v. So this is, we can write number 1, and here we can write using 1. So what we get finally? Therefore finally we get vxx, vyy, vzz equal to 2 by v, and this is our proof, hence proof. This is the proof. Very nice solution, very easy. Another problem, if v equal to ax plus by whole square minus x square plus y square, where a square plus b square equal to 2, then show that vxx vyy equal to 0. Now solution is start. Here given v equal to ax plus by whole square minus x square plus y square. We get this. Now first we find del v del x. Del x ax plus by whole square del x square plus y square. We consider this. But you know this formula, ddx of x square, this is twice x. ddx of x square is twice x. When you get twice x? If this x both are same. If this x same, then we get twice x. But here ax plus by whole square, this is x. These two are different. So this must be here. And v del x means we can write vx. We using chain rule, del ax plus by whole square by del ax plus by into del ax plus by del x minus, this is twice x plus 0, and this will be 2 same, x same is twice x, we get twice x. This whole means x square dx, twice x, and this is a del x, x means 1 and by is constant, this is 0 minus twice x. Ultimately we get twice ax plus by minus twice x. This is our vx. We get this. But our result is vxx. Again we differentiate partially with respect to x. Del x of vx. And this is twice a is constant, del x of ax plus by, 2 is constant, del x of x. We get this. And this will be this will be Vxx. This is twice A. If we differentiate partially with respect to x, then x is variable, this is 1, by is constant, and del x 1. So what we get? 2a square minus 2 we get. So finally we get Vxx equal to 2a square minus 2. We get this. Similarly, numbers is same. If we differentiate with respect to y, then we get again del v del y, del v del y, then del y ax plus by whole square minus del y x square plus y square. We get this, and this is Vy, and using chain rule, or we can write directly also, del ax plus by into del ax plus by del y. This is 0 plus twice y, and this will be 2ax plus by. We differentiate partially with respect to y, then x is constant. This is 0 and this is b into 1 minus twice y. So what we get? Vy equal to 2 into 2b, 2b ax plus by minus 2y. We get this. Now we get first order derivative with respect to y partially, we get this. Again, about our requirement, Vyy. So again we differentiate with respect to y. Del y. This is 2b is constant. Del y ax plus by minus 2 is constant. Del y of y. This is Vyy 2b. This is 0 plus b into 1. 2 into 1. Del y 1, this is del y 1. So ultimately we get 2b square minus 2. We get this. Now taking left hand side, in our left hand side we get Vxx plus Vyy. Vxx, we know the value. Vxx means 2a square minus 2. 2a square minus 2, and Vyy means 2b square minus 2. 2b square minus 2, and from these two, taking 2 common, we get a square plus b square, and minus 2 minus 2 minus 4, and also given a square plus b square means 2. A square plus b square means 2 given, this is 4, since a square plus b square equal to 2, this is given. These are given condition. So 4 minus 4, this is 0. So what we get? Therefore we get Vxx Vyy equal to 0. 0 we get. This is our proof. Hence, short. We have showed this. This is the proof. Vxx Vyy equal to 0. So, dear students, I hope you are all enjoying. If you are all enjoying, then please like this video. And if you are new in my channel, then please subscribe my channel for getting new videos and click the bell icon. Thank you.